I'm Warren Scott with Tektronix. I'm a certified LabVIEW architect and test stand architect. I'm going to talk to you about something I put together a couple of years ago that's been now changed to duplicate code detection. For those of you who aren't LabVIEW programmers or have a life outside of LabVIEW and have done programming elsewhere, it's also known as clone detection, or where have I written that code before? But unfortunately, clone has a different terminology and meaning in LabVIEW, and some people didn't like that, so I had to get renamed. Legal disclaimers. So how many of you have written this VI? Okay, only one? Or how often have you gone through and done something like this? I'm going to copy this code over and I'm going to make changes to it, or I need to protect it from my coworkers doing something stupid to it, or I don't like the name so I'm going to rename it, or I'm just way too lazy to build a honest goodness code reuse library the way I know I should. So I get copies of this VI everywhere on my hard drive or wherever. Or you're starting to search through your code and you realize that you didn't do this, but one of your favorite coworkers has done the same thing and duplicated their code all over the place just for something stupid like a scaling factor in VI or something else like that. Not to say this ever happens, but maybe. And the problem is, this is rather pervasive throughout any set of code that has multiple programmers and has lived for any reasonable amount of time. And the problem is, how do we find all of these and know that they're there, and then do something smart about them. We could do things like just look for similar file names, but that's never going to work because people don't use the same, don't even have good file naming conventions. We could do things like running block diagram cleanup now that that exists in LabVIEW and see whether they look the same or not. Or we could do the LabVIEW diff utility and see how different the VIs are, but that looks at lots of cosmetic stuff. And that also looks at how different they are, and we don't care about how different they are, we care about how the same they are, which is the opposite question. Or we're engineers, we can write our own analysis routine and figure it out ourselves because we can. So what we're looking for is how functionally similar are two VIs. Not exactly similar, but functionally similar. So if one has an add function, one has a subtract function, that's functionally very different, that's bad. But if they're kind of the same, if the front panel controls have different names on them, do I really care? Not so much. But if my wires have a couple extra bends, I don't care. So I don't need an exact determination, I just need something that kind of says, hey, this is kind of close, go look at it with something else. So I can take this VI, I can split it up into all kinds of little different snippets of one or two or three nodes and how they're connected to each other, and use that as a definition of what the VI looks like. So effectively I have an add node. I have an add node that is connected to front panel control. That front panel control happens to be a double that's labeled input 1 and has a value of 42 or something like that. And all this gets more and more specific as a definition of that sub-node structure of what is in that VI. What this means is I'm allowed to have small deviations and variations within the VI, and it will still rank reasonably highly as to how different these VIs are. So at this point, I've got the VI broken into small sections. I can compare these different subsections to each other, go down the list, and look at it and say, hey, these are really similar or not. What it comes down to is it's not going to be foolproof, it's not a diff utility, it kind of looks about the same. So the proof really comes out in the pudding, and you can go run this and do this yourself because it is posted up into the VI Analyzer Enthusiast community group, or I don't know, whatever it's called. And you can download it and add it as a test into VI Analyzer. Who's running VI Analyzer? Oh dear. Okay, we have a whole other subject to talk about at some point.
2 minutes.
Okay. Where'd my cursor go? Well, I've got that. I'm going to pull up the not gone through VI Analyzer because I have a different setup for it. I've got a folder of a whole bunch of code that I have sitting in here. And I'm going to copy into there a couple extra VIs that I had just written. And if I then go through and, yeah, the UI sucks, but we'll go back to the earlier presentations about writing good UIs. And then I have a list of the ranking of all the different VIs and how closely they are to each other. And if I look at something like these two guys, and the window all sucks because, oh well. Those two look pretty much similar. And trust me, the block diagrams are similar. If I end up going down all the way to the bottom to things that are very unsimilar, you will end up with unsimilar things that VIs that obviously are not very similar. It was just from front paths. So it's there. Go have fun. Enjoy it. Cool stuff to do. All right.